Welcome again to the Southwest Climate Podcast, Mike Crimmins.
Hey, Zach, stretching that intro out. That's good. I like that.
I've been practicing. How you doing?
Good. It's real good. The vocal coaching is going well.
That's the best part of my contribution to these. You know, it's that intro, and then it's just softballs for you. And so this is a November issue. Middle November. We're heading up into the frenetic holiday season. I don't know about you, but boy, like it just goes into like fast mode. It's highly variable, right? Like, you know, the work is like super fast paced the week before Thanksgiving, and then it like slows to a near stop, which is nice. And then the interim between, you know, before Christmas is like super frenetic, and then it slows down again. I don't know. It's
bewildering. I try to ease into the Thanksgiving holiday by trying not to work too hard in Monday, Tuesday.
for the prior 6 months.
Yeah. I mean, it's too hard on your body to like, you know,
you have like a nice like 6 month ramp up to.
It's basically all in service to my 17-year glide path towards retirement. So I'm trying that out right now.
The tenured professor.
I know, isn't it terrible?
Nah, you work harder than anybody I know.
No, that's not true.
Well, excited to be back. Sort of the overview here is spend a little bit of time recapping the last month and a half, beginning of October, really, when you know, sort of we think about the cool season beginning, and then talk a little bit about, you know, winter hazards, the hazard report. We'll bring that back.
Are we doing it in French? I mean, was that part of the hazard report?
The hazard report. Still a Colbert fan. And then end it with some, you know, outlooks and talk about ENSO and whatnot.
Sounds pretty standard.
Yeah, pretty standard. You know, we got a formula here.
Yep.
See how much we stick to it. But before that, here's maybe a curveball. We're in our own transition season, and I got to be honest, I feel a little lonely. And you know, just looking at you in the Zoom,
you see the fear in both of our eyes as we look at each other.
You know, if we were doing this with a video, it'd be like. There'd be a lot of sweat pouring off. So anyway, what we're talking about is, you know, our producer, our longtime colleague, Ben McMahan has transitioned out of, you know, the University of Arizona and on to bigger and better things, working on climate services in California. He has agreed to help us along the way, and obviously we'll have open arms for as long as he wants to help us out to edit this. But man, Mike, he really brought a level of professionalism and more than anything, competence to this.
I know. Do you remember the days when we first started this and we were using the reel-to-reel tape recorder and
oh my God. I do. I forgot about that. Yeah. Those were, I mean, we've been doing this for over 10 years now. So,
yeah.
And I also remember those early days, like having no clue how to do the editing and like the technical side of things.
We didn't edit it.
It was, you know, I do think there is an archive of that. Like I am scared to go back and listen to it. But the point was, I think as soon as Ben got here, he figured out how to make this useful, not only useful, but like functional and good sounding, and you know, consequently, like it's made, I think it's been a pretty good product. So very sad to see him go.
Yeah, no, he made us sound intelligent. So if there is now a sort of a decrease in intelligibility with the podcast, you're starting to see the true Mike and Zach show.
Yeah, hopefully we won't just have to like dump it online unedited.
I know. So anyways, Ben is still, the point is Ben is still helping us out graciously, but at some point he won't be able to do that because he's going to be too busy. So it might start to sound like basement recordings again.
And we're going to try to get Ben on and have him talk about what he's doing in California related to climate services, because it's actually really exciting. And, you know, Mike, you and I, and, you know, Ben for the last 7 years and other people, like we sort of engage in that world, but sort of more from an experimental side of things. And the downside of that can be, you know, it's largely in service of, you know, lessons learned and knowledge, but it's much harder to actually sustain it. It's actually quite amazing that we've been able to sustain this for 10 years. But the point is, Ben, you know, actually now gets to actually operationalize things and have have that be, really part of the decision-making process. Get climate and weather information streamlined into the decision-making process. So I'm excited about the prospect of having a conversation with Ben to hear a little bit more about what he's doing.
Yeah, he's got a real job. So that'll be fun, fun to hear about. Real job with real work. And yeah, he's going to make real impact with his program.
Okay, so with that, let's talk a little bit about, so we're mid-November. Had to think about that for a minute. Mid-November, let's cover October up until the present, and then we can move on, talk about the hazard report. But Mike, in my version of the last month and a half, there's been sort of two seasons. First, October was the first part of October. Let's say the first 2 to 3 weeks of October was actually felt like an extension of the monsoon. And I'm curious to know your take on this. And then since then, it has been, for the most part, dry in the southern half of Arizona with a little bit more moisture in the northern half. So might have, like, the monsoon seems like it left late. I dug back at the precipitation ranks for, statewide precipitation ranks. And, October in Arizona was, the 96th wettest out of, the period of record is 128. So top 25 percentile, pretty wet. And it was even wetter in New Mexico. So 112th out of 128, 16th wettest, something like that. So yeah, October was wet. So what's your take on what the heck happened at the beginning of October?
Yeah, so we had we recorded our last podcast October 4th. So that was when we did the monsoon recap. And I called the monsoon off the beginning of September. I said it was over. I did. I called it.
Yeah, we called you the punks.
Oh, that's right. I did peek my head out, and I think I did see my shadow, or I didn't see my shadow. I saw it or didn't see it, whichever way it broke at that point. September didn't quit. I mean, it wasn't gangbusters through the rest of September. We already kind of talked about this, but what I did not see coming was by the end of September, it kind of looked like the typical monsoon ridge was retreating to the south. We were actually starting to get those early season transition events, those troughs, those cold fronts coming across California. But by October 1st, we just went right back into early September weather, and we had a really strong ridge of high pressure build across the west, which actually led to a heat wave across the Pacific Northwest. And interestingly, it's a little counterintuitive, but that broad ridge actually caused it to cool down and become wet across especially the southern parts of Arizona and New Mexico, and it actually extended across the rest of the state. But for about the first week or so, under that broad ridge, we actually had a couple of upper level lows that wandered around. Some actually moved from east to west. And in doing so, the position of that low was able to draw up moisture that was, there's still some monsoon moisture hanging out just south of here in Mexico, and was able to draw it back up into the southwest and cause some pretty heavy rain across Arizona and New Mexico for the first 10 days or so of the month. And that kind of lingered right through the middle of the month. We were in this, again, waiting for the transition to happen. Ridge is still really strong across the west. Another upper level low forms right around the 15th. And then this one actually did start to move our sort of more traditional direction that we would expect from west to east, real slowly wandering, but again, was able to draw up quite a bit of moisture and produce some heavy rain, especially across Arizona around 15th, 16th, and the 17th of the month. Again, in your mind's eye, that pattern with that strong ridge across the west and this upper level low underneath it is actually called a Rex block. And that's a pattern where you don't have much movement of either. The low and the high reinforce each other. So we ended up having that pattern for a couple of days. So I'm talking about the 15th, 16th, 17th. In the 18th of October, it starts to break down a little bit. The high starts to settle, and all of a sudden, we see a pretty strong transition into a fall pattern by the 21st of the month. And then we have a really strong low pressure system come out of the Pacific Northwest and cover much of the western US with snow, actually some of that early season snow occurring across the Northern Rockies. And I just saw here too, I didn't remember this, Zach, but it actually snowed in Albuquerque on the 24th of October with this winter storm coming across. So we went right from this kind of monsoony action in the beginning of October, which is unusual for it to kind of hang into October, to a pretty strong winter storm across the western US on the 23rd and 24th of the month.
So then if we were thinking about the cutoff between when the monsoon ended, like we would probably look, if you're looking at the weather patterns, we would probably say sometime around like the 20th, 21st of October.
Yeah, I guess it's this whole thing of, is it the same kind of ridge that you get in the middle of the summer in the deep easterly flow, or is this more some kind of artificial pattern that could emerge in October that looks like the monsoon but really isn't the monsoon? I kind of lean towards the latter.
But okay, so maybe a partial answer to that is, was this really unusual? Because, as long as I've been paying attention, like I had never seen in October where I was like, wow, that looks like, a monsoon storm, a convective storm. I mean, it looked very, very monsoony, just visually, right? And, I hadn't experienced that late into the fall. So how uncommon is, and so the reason that this is a partial explanation is, because weather happens, right?
Yeah. Yep.
So how uncommon is it?
I can't remember an October quite like this. And so it's not to say that you can have a wet October, but typically it's tropical storms that will wander up through sort of a transition pattern, right? So that trough dragging in and steering the storms over the southwest.
And just to be clear with the transition pattern, like we're basically talking about the trajectory of the jet stream.
Yeah. So the transition is, there's a transition into the monsoon and then there's a transition out. And that transition is the subtropical high starts to build north across the continental US. And it's largely due to increasing sun angle and surface heating, right? And retract of the polar jet to the north. So there's a whole hemispheric sort of reorganization of the synoptic flow pattern, right? And so with that heating of the continent, you have the westerlies and sometimes a trough off the west coast get replaced by this mid-level ridge, right? Mm-hmm. So in that transition, though, there is wind out of the west, the southwest and the west in May and June, and that is dry at that time of the year because that fetch doesn't have much moisture with it, if any moisture with it. So that's dry, but it can still be windy out of that. And then the ridge builds to the north by late June and into July. And then if the high pressure system's in the right spot, which has been the last couple summers, the southern part of the southwest, southern Arizona, New Mexico are under easterly flow, and Mexico is too, sort of deep easterly flow on the south side of that high, right? That's classic monsoon seasonality right there. So that reverses, it sinks back to the south through September as the sun angle decreases and the continent cools off, and we start to get more vigorous synoptic activity in the whole northern hemisphere. So we transition out, right? So that ridge is replaced by troughs moving across the west. So we had that in the end of September, and then all of a sudden we had a pretty pronounced wave pattern in the jet that created that ridge to come back across the west. So it's not quite the same, as the climatological progression of the monsoon. This was more northern hemisphere weather scale change in the jet stream that gave us the ridge to come back. Does that make sense?
Yeah, and you are leaning toward it just looking like the monsoon, and there's other causes, like there's other drivers of that ridge that then looked a lot like the monsoon pattern, but it was just caused by a different set of circumstances.
Right, because monsoon, it points to a seasonal reversal in the wind, right? So that's not what this was.
But one question though about that, let's say those same sort of regional conditions happen with the highs and lows in the jet that created a high pressure, but a high pressure ridge, but that it happened, let's say, a week to 10 days later, would we still have, would that have been possible? Seems like it would have been.
Yeah.
And B, would that have led to the same amount of aerial extent of rainfall?
Yeah, that's a really good question. It might not have, right? So the climatology and that seasonality of moisture to the south also retreats. And so I think what you're saying here, Zach, is that the timing is good, right? Because right at the tail end of the monsoon, if there is moisture hanging around, anything you can do to bring it up here, and it's still a fairly warm time of the year. So the ability of the atmosphere to hold on to higher dew points or higher precipitable water is great. As the whole northern hemisphere cools off, we lose a lot of that precipitable water ability, or to have high precipitable water. It sinks back south to the tropics as well. So if it were maybe a couple weeks later and you already started to see subtropical moisture retreat to the south, we could have just had a ridge of high pressure that created hot weather across even Arizona and New Mexico, and or it could even had a cutoff low wander south of here, and it may have just been wind, maybe some high clouds, maybe not the precipitation.
Yeah, exactly. And it's also the case that ridge could have happened in the past, even earlier, late September, but the moisture in that particular season would have already sort of, left the region. And so it didn't actually generate like late September, early October rainfall. So,
yeah,
I mean, it does seem like it's a confluence of a number of conditions that allow for that rainfall to generate. But then one could easily make the point that isn't that always the case for the monsoon? Like, it's not like there doesn't need to be triggers for the monsoon, rainfall, within the monsoon season proper. It's a fine line between trying to define, I guess, the end of the exact cutoff of the monsoon season. But maybe the point, the worth retaining is that, yeah, there was moisture around, it was present, and we had this late season event that was forced by perhaps like non-monsoonal characteristic forcings that led to, pretty pronounced, like 2-week period of rainfall. I'm looking at these maps and it's like, from October 2nd to October 11th, there's rain in, 50% of the Arizona, New Mexico.
Yeah.
And then there's like a break, on 12th, 13th, and 14th and 15th of October, where it's probably clear blue skies, and then, as you mentioned before, the 16th, 17th, and 18th, there was another event that came through, another wandering low that really actually generated quite a bit of, I don't remember this, but it looks like there was quite a bit of rainfall around much of the Southwest.
Yeah. Yep.
And then maybe we leave behind the sort of residuals of the monsoon at that point, and are now sort of more into the transitional, seasonal, typical westerly influence, westerly wind influence from then on.
The subtropical moisture, that's a hallmark of the transition in the monsoon season, right? Is that building of the ridge starts to drag in the easterlies related to the subtropics and tropics, get a lot closer to Arizona, right? As you get into June and July and through the monsoon season. So it's much more proximal and so easy to work with. And as we get out of the season, we get into the fall, we lose access to that. And so when we're talking about subtropical moisture to get it into the region, it's now subtropical. We're talking all the way back to the subtropics, like south of Hawaii, so then it's those long fetches of getting subtropical moisture in across the Pacific related to the westerlies and the subtropical jet stream. So it really transitions. So I think what you're saying here too is that you got this moment at the end of the season where it's still close enough and you can actually work with it, but it wanes pretty quickly, and we're already out of it by this point as we're into November. And so now we've got to look kind of elsewhere to really drag that stuff up here.
So thinking about like mid-October to mid to end October to where we are now, mid-November, like for the most part in the southern part of the Southwest, it has been dry. Like Tucson, I believe it has not rained.
No,
it's been a little bit in Phoenix, but that's actually not the case as you go further north. Like Flagstaff has had a number of events actually of rainfall, and then the Four Corners region as well, right at the Four Corners, has also experienced a couple rainfall events in November. So, but that's split, right, Mike? Correct me if I'm wrong. So my mental model of like what a typical sort of transition or even like early part of the cool season looks like is that it's not uncommon to have more rain in the northern half of the Southwest than it is in the southern half, just because the storms themselves are they're not tracking as far south as, how do I say this? It's just less frequent that a storm would track further south than it is for a storm to track further north. So there's more opportunity for rainfall in the northern half. Is that more or less the correct mental model?
Yeah, totally. And it's also, if you think about the kind of common definitions of the desert ecosystems across the Southwest. So like the Mojave Desert is a part of the California Mediterranean climate, which is winter dominated. The Chihuahuan Desert is actually summer dominated and has a very weak winter signal, right? And we have both of those deserts in Arizona from north to south, and the Sonoran is the mix of the two. So yeah, what you're alluding to is that by the time we get into fall, we can and do in good years often see the precipitation start in the northern part of the state and hopefully extend south as we get deeper into the winter. So the better chances for southern Arizona and southern New Mexico to get into winter precip happens later than it does the northern parts of the state. And we've already, like you said, we've already saw that. So we've seen Flagstaff actually have a couple of snow events where they were just wind for the southern parts of the state.
So to me, that begs a question. In my mind, there's like three different characteristic storms that the Southwest can get. There's a wet and cold version. There's a wet and dry version. There's a cold and dry version. And I'm leaving out the warm and dry because—
Did you say the second one was wet and dry?
I did say that.
Okay.
But I didn't mean to say that.
Okay. Because I was already trying to grok that one and figure that one out.
That was thank you for correcting me. No, that's seeing how much you're paying attention and
hey,
how fast your brain works. All right, let me say that again.
Okay.
So there's a wet and cold. There's a wet and warm.
Okay. Yep.
There's a dry and cold.
Yeah. Good.
And I'm leaving off the warm and dry.
Okay. Yep.
Because that, to me, a warm and dry for a winter storm seems—
it's a little weird. Yeah.
Is that correct though?
Yeah. So do you want to step through these? We'll leave that as a weird contingency that maybe we could reason out. I'm not sure.
All right. So the question is like, I'm just curious, like what the regional pattern would be to create these different scenarios. So we can step through them. So let's take the wet and cold version first.
Okay. So wet and cold. So let's think about wet and cold and dry and cold together because they're really pretty similar. Okay. So wet and cold storms they're great storms that can bring quite a bit of snow to Arizona. And those are also the storms that we can think about in the last couple of years that have happened. They usually happen somewhere in sometimes December, more kind of January, February, sort of the heart of winter. And those are the storms that actually can bring snow down to the valley floors across Arizona and New Mexico, right? So those have low snow levels. Those are typically storms that have inland tracks. So they're forming over the Gulf of Alaska and then progressing down the West Coast and have an interior track, which actually makes them cold, right? So then if you can imagine that they're part of a polar air mass that's coming out of the north. And they also have to have enough moisture with them that the moisture can make it all the way this far south. So it's got to be a pretty specific,
juicy.
Yeah, it's got to be juicy. So it's got to pick up some moisture somewhere out of the Gulf of Alaska, and then it's got to be able to sustain it all the way to the south.
Which is always remarkable to me, because when you look at the West, right, it's got to thread the needle between a bunch of different mountain ranges, right?
Yeah, and that inland track is actually it's tricky too, because that's typically dry, right? So those storm events are actually kind of rare, right? Sometimes they can pick up moisture a little bit further down the coast, but that often warms them up a little bit, right? So then they're not quite as cold. So they tend to not be super wet, because the colder they are, the lower the amount of precipitable water that they can hold. So they tend to not be super wet events. They can be, they can do, decent amounts of upper level, higher elevation snows, but they can drag them down to lower elevations as well.
So
right?
The wet and colds are not all that typical.
No, right.
For those reasons that you just said. And it seems like the wet part of this, like, it's pretty critical what the conditions are like in the Gulf of Alaska.
Yeah, and you can imagine the jet's got to have a huge kink in it too, right? It's got to have some kind of huge wave ridge in the Eastern Pacific, and then it's got to have a really strong digging trough across the West with that low, right?
Is the trajectory of that jet, does that matter? Thinking about like the threading like sort of the right position so that, the topography doesn't sap all of the atmosphere of the moisture as it makes its way into down sort of from the northwest of us into our region.
Yeah, I would think, I'm trying to think in my head here. It probably can't have that long of an inland track, because it would dump all its moisture.
Right.
So it might, it's probably some threading the needle over where it's some Gulf of Alaska down western coast of Canada, maybe even the Pacific Northwest. You could do that. The trick is that the more moisture a storm has, is it's typically a little bit warmer too, right? They scale with each other. So it's a really interesting pattern, and sometimes it can be too where there's maybe a little bit of leftover moisture from some previous event, and a cold air mass is interacting with that and is able to do that. Those are even, I think, weaker as far as producing widespread snowfall. But those are the ones that give us where we get the picturesque snowing on a cacti kind of situation. And you got to think about too, it's harder and harder to do that in a warming climate, right? It takes an even more specific, jet stream pattern to be able to steer cold air of that quality and magnitude this far south to be able to do it. It probably was easier. I mean, we've got really great widespread snow events in the records of the 60s here in Arizona that probably had a different synoptic pattern that maybe was a little bit more relaxed and easy to make those snow events.
Interesting. Okay, so dry cold.
So the dry cold, I think, in my mind, looks a lot similar, but is even more inland.
Right.
And it's dragging a low that's almost dropping straight south out of interior Canada and moving straight south through the Great Basin, and then dropping and bottoming out into Arizona. So remember our classic crazy freezing event of is it 2011 or 2012 when we dropped down into the teens here? And
I think so. Is that the one that there was actually a disaster declaration declared?
I think that's right. And it was
region.
And it killed palm trees, and it was crazy, and all sorts of things. We talked about that a lot I remember this back in the podcast too. The synoptic pattern had the isobars straight north and south. So it was literally just like a funnel of cold air straight from the Arctic down into the Southwest.
So how does that differ then from actually the current conditions?
Like today?
Yeah, or this, and what's forecasted for the next couple of days, because it's like going to be pretty frigid across the West.
Yeah.
You mean to tell me you haven't looked at the weather maps?
I did actually, did about an hour ago, but I looked at so many of them I couldn't remember.
I'm drawing, a picture of what those geopotential height maps look like, and it was sort of like almost like a vertical configuration from the border region down into our area.
Yeah, it's similar, but what's more typical is that you get the cold polar air masses typically move from interior Canada, and they slide into the northern Rockies, and the cold air usually pours in on the east side of the Rockies, right? And then it literally just pours south. So all that cold air it literally gets dammed up against the Rockies and then can spill all the way south through Texas and then, into the Gulf of California. And sometimes
it goes the other way.
Yeah. Because the westerlies are trying to steer all of these air masses from west to east, right? And
right.
If the jet stream if it's progressive in a little bit, meaning that its wave pattern is not too kinked, that those waves are still going to move from east to west. But like that event we talked about in 2011, I mean, there was a huge wave pattern in the jet. And as you get those really high amplitude meridional wave patterns, they move slower, and sometimes they can reinforce themselves. So they'll kind of crank down and slow all those air masses down. And then you can steer polar air masses from north to south and maybe even slightly to southwest, right? But those air masses are really in the mid latitudes, and in the fall and the winter, they're forming in Canada, and they're moving out over the northern Great Plains and into the Midwest, and then off to the east, which leaves us typically in that warm air mass in the southwest, right? So to shove the warm air mass out of the southwest, you got to have stuff come straight out of the north and maybe even kink back towards the southwest. Just doesn't happen every year, right? The Arctic oscillation, when the Arctic oscillation is weak or negative in the winter, you get a sloppy polar jet, and then you can have all sorts of dollops of cold air come down across the west, the central US and the eastern US. And under a strong positive Arctic oscillation, it gets all bottled up, and then we're kind of in a mild air mass.
Wet and warm.
Okay, so wet and warm, that's what I think about is immediately the classic El Nino winter. So that would be a strong subtropical jet, which is different than the mid-latitude jet we were talking about right now. And that is going to come in across the Pacific. Sometimes we would call it a pineapple express, depending on where its origin is. And that would then lead to very high levels of precipitable water or moisture. And if there was cold air to the north, that would even enhance the dynamics a little bit. But those kinds of storms are moisture rich, but don't often have a lot of cold air with them. And they can produce heavy rain across the southwest, but have high snow levels. And again, those are more common during El Nino years.
And those are the ones that you can really get these catastrophic flooding events, right? If you're going to have a snowpack at least in Colorado and Utah, and probably to some degree in northern Arizona, New Mexico, but a bigger snowpack obviously in Colorado and Utah. And then if you get these warm and wet storms that drop copious precipitation, but also like are pretty warm, it's going to melt that snowpack.
Yeah, I mean, rain on snow events they're really problematic for the Southwest, because I think they would be a little bit more common down here, because we could build a snowpack, and then we're far enough south that you could get that kind of warm, wet storm that would produce the melting with the flood and the flooding subsequently.
So the El Ninos, the wet and warm are more common in El Ninos. Would the dry and cold be more common in the La Ninas?
I think they actually slightly are. And you see a slight tilt in the odds towards cold extreme. Again, this is not perfect, because largely La Nina in the Southwest leads to overall above average temperatures. But there are, if you look at the temperature distribution, there is a slight little lean that you can get these cold outbreaks as well during La Nina winters, right? So you get more of an extreme. And El Ninos tend to be on average cooler just because there's so much more precipitation. But it's a little counterintuitive but they're often, those storms are warmer. So on average, El Nino winters are cooler because it's raining more, but it doesn't necessarily mean that those are colder storms, and vice versa for La Nina events.
Okay, Mike. So let's now talk a little bit about the different hazards in the winter period. So main hazards, what comes to mind?
Was that a question to me?
That was a question.
Man.
It also was clearly a statement that ended in a period.
It did end in a period. Okay, so what are the main hazards in the Southwest during the winter?
Yes.
But you already know the answer, so you're just testing me. We can have flooding events in the Southwest. They tend to be more widespread, and we can have river flooding associated with heavy rainfall with storms by themselves, but also rain on snow events. So we have that interesting extreme. We also have the other extreme, which would be persistent drought through the winter as well.
I was actually thinking you were just going to talk about drought. I didn't realize, you're on it, because we tend not to think about, I feel like in the Southwest, I feel like what dominates, and maybe it's like, because we've had two La Ninas in a row, and drought is such a collective trauma that I feel like, the drought signal is so present here. But you're right, like, there's flooding that happens quite a bit, and those probably can be more likely associated with atmospheric rivers, which tend to be a winter phenomenon. I pulled some data from the National Oceanic and Atmospheric Administration Storm Event Database. Is that right? Is it known as
the local storm report database?
Yeah.
Yep.
So we actually did this. I shouldn't portray it as if I just pulled the data. We actually did this for a project working with the Federal Emergency Management Agency a while ago. And so we did climatologies, but I just resurrected those maps that we created, and we looked at flood impacts and flash flooding. There's like a real presence, particularly of flash flooding of these flash floods in December and in January, particularly for flash floods, particularly in Southern California, but also in central Arizona. February as well. The flash floods are present during the winter. Floods, larger floods, are also quite present January and February. More so, I would say, it shifts a little bit more to Southern California, January, February, March for Southern California. And then in January, there's the presence of flood impacts in Arizona as well. And obviously, those are all flooding and flash flooding impacts. The predominant signal from those are during the monsoon season. But the point is that they also occur in the winter season. So drought, floods, freezes. We tend to talk about this less, that they're not as common. What are we paying attention to this year?
So it's a La Nina winter, the third one in a row. So drought will be another. The persistent drought, or the expansion of short-term drought conditions, will probably be back on the radar again. We've done so well with the summer rainfall. Even, quite honestly, as we talked about, the summer rainfall this summer was so much better for short-term drought improvements than it was even the previous summer, because of how frequent and widespread it was. That I think we really have beat back short-term drought conditions pretty well, but that will probably expand again as we struggle with some winter precip with the La Nina coming up. So I'd expect that. These La Nina events, we've seen this in past years too. Widespread freeze events are still going to be a risk. I mean, there are places that it freezes regularly across Arizona, higher elevations, but having those reach into low deserts is always a risk, especially during dry winters as well.
We're in the midst of the third La Nina event, back to back, triple header, triple dip. It doesn't happen very often, right?
It does not. No.
I think it's not unprecedented. I think this is the third such back-to-back-to-back La Ninas in the observational record. So probably 1950 or so. So, that's not unprecedented, but doesn't happen very often. But I look back at the drought signal starting 2 years ago. So, at this time, 2020, much of the Southwest, actually much of the West, let's say Colorado, Nevada, Utah, Arizona, and New Mexico were under extreme drought. And we basically had a pretty dry winter, a very dry winter, actually. And so fast forward to March of the next year, or May of the next year. So 5 months later at the end of that winter, and it's like drought had expanded, at least according to the drought monitor, US drought monitor, pretty much to be exceptional drought, which is their highest category, right? And the rainfall across 95% of those 5 states were below normal, with the sort of the Arizona and New Mexico, much below normal. So that's what you would expect. It was also probably warmer. And then what really saved us then was the monsoon. So the 2021 monsoon 2 years ago, like the generational monsoon, as we were calling it, we started that season, the winter season, with moderate to severe drought. And again, we had another very similarly dry winter across the West. And drought expanded, but didn't reach the 2021 levels, the year before levels, right? So it expanded to a severe drought, maybe extreme in a few cases. I should say New Mexico was worse off. I remember talking about this, was worse off in terms of drought than Arizona was, but it wasn't to the degree that it was the year before. And then what saved our butt was this year's monsoon, which was generational again, which we shouldn't say that twice in a row, but it was. And so now the picture, at least according to the US drought monitor, right, is one where we're in a better situation than we were the previous 2 years. There's some drought, abnormally dry conditions, which technically I don't think are like, people call those like drought, but abnormally dry conditions around for most of Arizona and New Mexico, with some moderate and severe drought in parts around the edges. And we'll see how it goes. The expectation, of course, is that it'll be another dry winter, right? And again, so after the end of both those, the previous 2 winters, we were really talking about how much pressure was placed on the monsoon. I guess I would say this, Mike, given where we are now, like even if we have a similarly dry winter as we've had in the last 2 years, we won't be in as bad of a situation as we were at the end of the winters of the last 2 years.
Yeah, I think
given by where we're starting.
I talked to some land managers and some ranchers who work in Southeast Arizona just a couple of weeks ago, and they were commenting on how the summer rain this year was some of the best that they have seen in decades, and they've seen such an improvement of the range condition that they were pretty astonished, right? And that was even after last summer was quite good as well, right? So that's pretty remarkable. I mean, in most respects, based just on that particular metric, you could say there's really no short-term drought. But drought is about timescales and sectors and specifics. So we can have all of that going on where we have these really great short-term seasons that do good work for when the precip was needed, but at the same time struggle at longer timescales, right? So the reservoirs are still a mess. We still have very low reservoir levels, not only on the big reservoirs, but even some of the ones across the region are not in great shape because of the lack of winter precipitation. So it's hard, right? The missing winters leads to its own set of impacts that can't be made up by having good summers. So you can have both pretty bad drought conditions even while it's raining a lot. It's just not raining at the right time of year, producing the right kind of water for the system.
So you're in conversations about drought monitoring, both at sort of the national level. I think you tune into like how these US drought monitor maps actually get made. I mean, at least you're tuning into those conversations, but you're also tuning into the conversations that are happening around the state just by the nature of your job. And I'm just wondering, like maybe like thinking back on the last 2 years, as drought, particularly 2 years ago, as drought was a pretty bad situation, going into the winter. Like, how do those conversations evolve? Like, do they increasingly get more frequent in terms of just the level of concern and the number of people that are chiming in, like, or is it just sort of like a slow burn, like drought itself is sort of a slow burn? Give us a little insight from like behind the scenes, like the people that like are paying attention for their jobs. Like,
well,
how does this conversation go?
So the Arizona State Governor's Drought Task Force and the Monetary Technical Committee actually make contributions to the U.S. Drought Monitor, which is updated every week, right? So there's an ongoing weekly conversation no matter what, right? So no matter if there's drought conditions or not, there's this ongoing coordination and discussions about current conditions, right? So there's that. But who's paying attention to what, when, varies, right? So if you're land manager or rancher, there's seasonality of rainfall that's really critical. And if you miss that, you have impacts that can't be made up by a subsequent different season of rainfall. If you're thinking about fire, that has a seasonality too. So if there's long-term versus short-term drought, that's going to lead to drought conditions in different fuels. And you're going to pay attention to that map largely certain times of the year and use it for planning. And then if it's water, it's like this slow burn long-term problem because of the longer-term drought conditions and warming temperatures are just sort of shifting the whole water resources picture in the region. And that's why it's really challenging. I was looking at the Drought Monitor time series, the area extent. So the Drought Monitor started in 2000 and it's been going ever since. In 2019, it's hard to even remember pre-COVID times, but in that whole 20-some year period of the Drought Monitor, the extent of drought across the U.S. on the Drought Monitor map was at its all-time low in April of 2019. And if you can kind of remember, in even in the Southwest, in the summer of 2019 was not a particularly wet monsoon. That was one of the ones we complained about. We had no idea that 2020 was coming, but that fall was actually really, really wet across the Southwest. And so, kind of beat stuff back. But from 2020 on, it's just the extent of drought has exploded across the continental US. And we're talking about drought just about everywhere. And we're almost now at the highest extent of drought across the continental US that we've seen in the whole Drought Monitor history. So we've seen both extremes just in the last 3 years. And to kind of bring it back to the Southwest, it kind of depends, right? It depends on cool versus warm season precip, who we're talking to, and what kind of impacts you'd expect or you're worried about in the sector you're working.
I was taking a look at that time series too, actually, and I was just scrolling through the different dates and scrolling through the different maps, and it's obviously a huge country. I was looking at the national level, and so like, aside from that one period that you were mentioning, like, and there was still drought present. It was just in like,
it wasn't zero. Yeah, it wasn't
zero, but
yeah.
But there's usually some extreme drought or severe drought somewhere. And, it's usually in one of two places. It's usually in the arid West, which is an obvious thing to say.
Yeah.
Right. Or it's in like Texas. It's like there's a few places like the Pacific Northwest, the Midwest, like they don't nearly get it as much as we do in the more arid parts of the West and Texas, which is kind of an obvious thing to say. But I think it's not like it's not raining there, and it's not like it's not raining, or it's not like it's not below average rain in those places, right? It's just when you have 12 inches of rain in a year and you're at 75% of average, those 3 inches are pretty consequential. And when you have, let's say, 30 inches of rain and you have a 3-inch deficit there, not the same percentage, obviously, but it's less consequential, right? So we're just like in that area where it's like a few misses here and there is pretty telling. It's pretty impactful in terms of drought. We're just going to have drought, the nature of our climate.
Absolutely. And it's easier to fall into it and it's harder to solve them because precip is low. It's kind of an obvious thing to say out here too. We also have this real challenge, I think, out here in the West too, of like short versus long-term drought. And, some of the drought monitor maps are trying to do, well, the drought monitor map tries to do both, right? And so long-term drought can happen over decades. We have decadal variability, teleconnections, especially in the Southwest. So you can get into like what we're in right now, where do you show that long-term drought, that long-term deficit on the drought monitor map? It's going to be on there for 20 years. It could be on there for decades. And so I know that that's always been a struggle too, of short versus long-term drought here.
Fantastic. Well, let's move on.
Yep.
Let's end this with a little bit of our ideas or our knowledge about the upcoming winter season and what that may bring, what the models are saying. So let me, we already talked a little bit about this being the third La Nina in a row. And so from that, given that it's the leading predictor of seasonal climate, still not like a slam dunk, it's pretty clear if you look at the models, it's pretty clear that they're picking up on that dry La Nina. They're picking up on the classic sort of La Nina pattern of wet Pacific Northwest and dry sort of southern tier of the U.S. In fact, I think only one of the models that I'm looking at right now, their ensemble has just a wet signal, whereas the 7 other ones. So I'm looking at the CFS version 2. I'm looking at the Canadian model, looking at GFDL's model and NCAR's model, NASA's model. They're all, aside from the NASA model, they're all painting a drier than average winter in the Southwest. So I don't know if you have anything you want to talk about there, Mike.
The La Nina strength and persistence is somewhat similar to last winter. We're not talking about like 2002 level dry conditions, which we've seen in the past, which wasn't even technically a La Nina. But some of those really dry winters, I don't know. I'm trying to be optimistic, right? If we could squeak out a couple of good cold snow events, well timed, maybe we could build a little bit of snowpack that will help with the short-term water situation and helps cut the time on the spring fire season. That's about as good as I'm hoping for right now. I don't think these models are wrong. They're the anomalies or the sort of shift in the strength of the forecast it's a little bit weak for the Southwest, and it always leans into southern Arizona and New Mexico as having a higher probability of below average precip. And it's exactly what we talked about earlier, is that those aren't particularly wet spots during the winter anyway, so it's just a little easier for them to miss out on storms. I think all eyes will be on the Colorado River upper watershed this winter just to see what we're going to be able to do as far as precipitation. And Zach, I'm looking at a couple of those maps too. The ensemble from the European has the upper Colorado right at the pivot point between dry to the south and wet to the north. So where will that dividing line be? It's going to be a real question. Right.
So that's interesting too, because you brought up snowpack. So and obviously, like, the sooner that you can put snowpack down, the better. And just in terms of like more is better. And like if you have a dry beginning, it's just harder to catch up.
Yep.
Right. And I mean, right now it's like in the very beginning, but there is snowpack down. It's highly variable across the West in terms of the proximity of stations. Some are above, some are below. So there's a lot of variability, but like in aggregate, they're trending, at least on the western side of the Rockies, they're trending above average, which I think is a good start, at least. So if I looked at the Colorado River headwaters, slightly above average in aggregate. The Rio Grande headwaters are above average, 115% of average right now. Let's see, the Gunnison is 130%. It's not a bad picture early on, but it's obviously very, very early. But the other thing that I think is interesting is I looked up the stream flow forecasts, which basically, they account for what they think is going to happen, and also what's already fell in terms of snow water equivalent. And so obviously, as you go further in the winter and more of the season is past, and we know what happened in the past, obviously those forecasts become more accurate. So right now it's fairly uncertain forecast, but for the most part, Colorado and Utah, there's many that are much below average. So the inflow into Lake Powell is projected, the April to July forecast is projected to be about 70% of average. So even though they're on the hinge line, these forecasts, whatever's in them is sort of hedging toward a little bit of a dry signal. Now, I should say that many of the other ones are, 70, 80% of average. Rio Grande at that Ottawee Bridge is 65% of average. So that's usually a telling position on the Rio Grande. For the most part, they're either below or much below average for streamflow forecasts. So,
yeah, I mean, it's pretty early to issue a streamflow forecast. The best streamflow forecasts are based on snowpack that exists rather than snowpack that doesn't exist.
That's right. So we'll just keep an eye on that.
The La Nina winter teleconnection is typically wet over the Northern Rockies and the Pacific Northwest and dry across the South, but the upper Colorado River Basin is right in the middle. It hasn't broke favorably for the basin in the last couple of years, but wouldn't it be great if they got a little bit of snow this year?
All right. So are you bullish or bearish? You must be.
I don't know. I'm coming off the afterglow of the monsoon in the wet October, and just I don't know. Got a little bit of positivity here. Thinking, why not? Let's give it a shot. See if we can make some precip this winter.
Of course, that belies what you were saying offline, Mike.
It totally does. Yeah, it totally does.
I only mean to say, and we didn't talk about this. We don't have to, but you're like, I don't know if it's if there's a transition from La Nina into ENSO-neutral and La Nina, which some of the models are picking up on, that might have implications for our monsoon. But we don't have to talk about that.
But I will
we'll keep an eye out on that.
I'm a little nervous already for the next monsoon. I mean, it's crazy for us to talk about it in November, but
I'll say this just by virtue of the past couple years, that if we do have a dry winter, and again, pressure is put on the monsoon season to deliver. I mean, it's one of these years, just by chance, it's
gonna break.
Dry.
Break.
So
we can't keep this kind of luck up.
Can you imagine though if we had these three La Ninas back to back with like pretty dry monsoon seasons? It feels pretty lucky that we had the monsoon seasons that we had.
You don't have to look too far away from the Southwest to know what that looks like. That's where some of the deepest, darkest reds in the drought monitor map are. They don't have strong monsoon signals, so they don't get a lot in the summer, and they didn't get a lot in the winter. That's what we would have looked like too. We'd have been.
Well, that's the analog, yeah. Those places that don't get summer rain and just picked up on the winter rain and snow that we got. So
Yep. Don't have to go too far away to know. It's pretty miserable. So, gosh, we've been lucky here. And again, like thinking back the last 6 weeks, getting that clouds and rain in October took the pace off the temperature, kept us below average to below average. And then fall came in. It's just been really quite pleasant here in the Southwest. We've been really lucky.
Well, thanks, Mike. We'll come back sometime before the holidays, hopefully in December.
We might get canceled though without having Ben as our producer anymore. I know. I just think that we'll just keep trying to, keep this hacky thing going here.
Yeah, we got to come up with a plan.
We do.
All right, everybody. Thanks so much for tuning in. As always, have a good rest of your month.
Yep. Happy Thanksgiving, everyone.
All right. Let me stop this so it can start. How do I stop recording? Let me start this segment over again. Ben, sorry. This is why we need Ben.
I think we just post it as is.
This is why we do segments.